We're in Module 3, Novice Problem Solutions, and we're going to look at 9 now. 9 is the last of our hypothesis testing problems. Just as a reminder, remember now that hypothesis testing is about asking questions about a statistic from the data that we have and comparing it to a statistic of a population. In most cases, or often it's the case that those statistics are means or proportions or sometimes standard deviations. Also remember that in the one sample test, what we were doing is comparing our sample that we had collected to a standard, to some population standard. For example, let's say we're trying to join thinking about joining a professional organization, and they give us a statistic of some average. Let's say it's the average income of some sort of sales group. And we want to ask, is our average from our organization significantly different from the population distribution that is given to us as a standard? This problem is about comparing two samples means to one another. So we're moving away from one sample test to two sample tests. We want to know if there's a difference between these two means. So the question here is, we've got Lupe, who's angry because she's done extremely well in the ultimate mixed martial arts world, the intercollegiate world, and she's angry that the men have been responsible for putting them into the puny but smart bracket. She'd rather not be there. And you say, well, we can test this. We can see if there's a significant difference between the weight of the men and the weight of the women. We know from our sample that there's a difference, but can we make some sort of a probability statement that says, hey, I believe that there's a significant difference between the weights of the two? So let's build our hypothesis test, and the hypothesis test in this case is that the mean for women, the weight, mean weight for women at William and Mary is equal to the mean William and Mary men weight. So the alternative to that is going to be either that the mean for the women is greater than the mean for the men, which is the evidence that we have from our sample, we'll see later, or we can take a more balanced look and say, look, we just think it might be different. So either one is okay. It's up to you. You choose. I think I'd choose the first, since I have evidence from the sample that that's the case. So how do we deal with that? Well, first of all, we can use, by the way, Minitab, or we can use Excel to do that. And now we don't have to go through those crazy gyrations that we went through before in calculating the t-statistic and then the critical values and all of that, because the software we have in both Minitab and Data Analysis Toolpak will allow us to do that. So here's our data, the same old data that we had before. And I need to break this data up into men and to women. One way of doing that, obviously, or the important way of doing that, is to take our data and to sort it. I want to sort from, I want to custom sort first of all, because I want the key to be the gender. I hit OK. And now I've got all the men and all the women, and I'm going to need to make those comparisons. So I need to separate the data out in preparation for the analysis. There it is. So let's do the analysis. Let's do first the Minitab version of it. And I'm going to do a one-tailed test, first of all, that suggests that the difference is less for men than for women. So let's grab our data. Let's go to Minitab. I've already got the data in here for men. I just cut and pasted, and women. And I'm going to go to Stats, Basic Stats. Then I'm going to go to two sample t-test. This is the preferred test. Each sample is in its own column. There are other options, but in case I usually put things in its own column, and we can get these guys out of here and just rebuild this. Let's put the sample 1, the women, in the first sample, and the men in the second sample. And then I want options, and I want the hypothesized difference to be less, or the difference to be less than the hypothesized difference. And the hypothesized difference is going to be 0. I give it my confidence level, 95%, or that's an alpha of 0.05. 1 minus 0.05 is 95%. Hit OK. And then I hit OK here, and I generate values. Now notice the very large p-value that I've got here. That in a sense is the problem, because I mix the two values up, that the mean of the women was less than the mean of the men. So let's go back and fix that. Let's go to the graph, to stats, basic stats, and let's go to two-sample t-test, in this case options, and let's go to the difference is greater than a hypothesized difference of 0, because we're subtracting men from women. I hit OK. And here we have the outcome, and the outcome tells us that there's a p-value of 0.43. And as we know from before, our comparison for this one sample test, we compare 0.043 to 0.05, and 0.043 is in fact smaller than 0.05, so we can reject the null hypothesis. Here's my information. Here's the data that I just generated. So we reject the null hypothesis because 0.043 is less than 0.05. Let's do the two-tailed test. Let's go back to stats, basic stats. Let's go to two-sample t, and then let's go to options, and then let's go to a two-tailed test, which is that there's a difference. I just don't know which direction it is. So they're just not equal. Hit OK. Hit OK here. And the result returns a p-value of 0.085. Of course, 0.085 is larger than 0.5. So for the two-tailed test, I cannot reject the null hypothesis. Kind of an interesting result, right? So when I know less, when I know nothing, the two-tailed test says, no, you can't reject. But when I have the sense that, wait a minute, I think the women weigh more than the men, then I can reject. And of course, that's the evidence that I had from my data. So now let's do the test with our data analysis package. And you can see, here's the results. The results are quite nice from the data analysis tool pack, because it gives us both the one-tailed test and the two-tailed test simultaneously. So let's go to data analysis. Let's go to t-test, two samples, assuming unequal variances or unequal variances. I don't know what the variances are for these, so I almost always choose unequal variances because it's the more conservative approach. I'm putting less restrictions on this condition. So here's the data that I need to insert. I need to give it the range values for each one of the variables. You can see T24 to T47 is one variable that is men, and then the women, that's women, and then the men are going to be T3 to T23. We can get rid of those if we want. I'll show you how to do that. So where do I find my data for women? Right here. Here's my data for women. And then I don't have labels, so my hypothesized difference is 0. If you don't put anything there, it'll assume 0. Here's my alpha, and here the output range. Let's make the output range equal some other place. Let's put it right over here. Let's hit OK. Here is our outcome. Here is our p-values. Here are our p-values, and you can see from the outcome that we have a p for a one-tailed test of 0.42, very similar to what we got up here in the test for the Minitab 0.043, I mean, it's a 1,000th difference, it's rounding. And the two-tailed test is 0.849, almost 8.5, which is what we see here for the two-tailed test. So very compact. We reject the null hypothesis for a one-tailed test because it's smaller. 0.04 is smaller than 0.05. That's when we reject. But we can't reject because 0.08 is in fact greater than 0.05. So we can't reject in the two-tailed test, just as we did before. All right, that's hypothesis testing. There are a lot of resources out there. If you need to go someplace else, you can simply Google hypothesis test. The book does an excellent job of laying this stuff out. And that's the end of Module 3.